Okay, a group of RHS students decided to study the sinusoidal nature of tides. This, by the way, this worksheet was obviously created by another teacher and put online that I'm using. Values of the depth of the water level were recorded at various times. At t equals 2 hours, low tide was recorded, which is 1.8 meters. At 8 hours, high tide is 3.6 meters. So part A is sketch a graph, write the equation, and part B is give the depth of the water at 21 hours. So the first thing I can find is midline because I was given a max and a min. So um, minimum 1.8 plus maximum 3.6 divided by 2. So this is what? 5.4 divided by 2. And that would be 2.7. So the midline is 2.7. The amplitude is the distance between the midline and either one of these 2 points. So like 3.6 minus 2.7 is what? 0.9. So there's A. And we can get some of this graph to figure out the period and any sort of shifts we have. So the midline is 2.7. The minimum is 1.8. The maximum is 3.6. At time 2, we're at low tide. And then at time 8, high tide was recorded. So once you get this low tide number from here, you know the graph has to go back to midline somewhere. And then high tide, so we know that's at 8 hours. And then midline and then low tide again. And we'll use the fact that half of the period is 6 to get that the entire period is 12. Like this must be at 14 hours because these graphs are symmetric. So the fact that it took 6 hours to get from low tide to high tide means it'll take another 6 to get from high tide back to low tide. So that means that the period is 12, and we set that equal to 2 pi over b. B is going to be 2 pi divided by 12, so pi over 6. All right, and if we're talking about building both a cosine and a sine function just to practice for our AP exam, the phase shift, if we're looking at a cosine graph, which is what this looks like to me, one period of cosine, that would be shifted to the right 2 units. So C is going to be minus 2. If we're going to look at a sine curve, we need to figure out, first of all, where we want to start the sine curve. I'd like to start right here and let it continue on. So I need to figure out, well, how far is that? So you could either say, well, it's halfway between 2 and 8, or remember this value is always the first shift, 2, plus every unit is 1/4 of the period away. So 2 plus 3 is 5, which again makes sense because 5 is between 2 and 8. It's 3 units away from each. So if we're looking at the sine graph has been shifted to the right 5 units, so minus 5. All right, so writing the model, it doesn't tell me what to call this one, I don't think. So I'm just going to say y equals, the cosine function is negative, so it's going to be minus 0.9 cosine of pi over 6 times t minus 2 plus 2.7. There's the cosine model. Same graph, but a sine model would be a positive 0.9 because the sine graph opens up. Sine of b times t minus 5 plus 2.7. So either model should be correct. And then the second part of this was give the depth of the water at 21 hours. So find y of 21. So on my calculator, you need to make sure on your calculator that you're in radian mode. If not, go to mode and switch it. And type in either one of these two functions. So 0.9 times the sine of pi over 6. If you type it in exactly as you're writing it, but you're putting in a 21 right here, then you shouldn't have problems with parentheses. So I'm typing in exactly what I have, and I'm getting 3.479. And then I believe our label on that is meters. We always want to label our answers for applications. Yeah, meters. All right, so this is the solution set for the first problem. For number 10, an object attached to a spring oscillates around a stable equilibrium position according to the position formula given by this. So they gave us the sine function for this one, where t is in seconds and s of t is in feet. What are the period, frequency, and maximum displacement from the stable equilibrium position? So this one's great. We don't really have to do any graphing or working backwards. This is going back to like our beginning days where we just had to figure these things out based on the formulas. So what is the period of that function? It's 2 pi divided by b, and b is 3 in this case. So if I wanted to label this, let's see, the period is the amount of time it takes to complete one cycle. So this would be 2 pi over 3 seconds per cycle, I guess is what I could say. That's how long it takes to complete one entire sine wave here. And then the frequency is the reciprocal of that, so 3 over 2 pi. And then what would that be? So it's the reciprocal, like literally flip these around. That's how much of the cycle is completed per second. So this didn't ask me to label this, but I think that I anticipate multiple choice questions, including labels maybe, or explanations of period and frequency beyond just finding those numbers. And then maximum displacement, that's also known as amplitude. So the maximum displacement, how far will the max and the min go from equilibrium? The maximum displacement is equal to 8, and the label on the position is feet. So that's all we have to do for number 10. For number 11, an object hangs from a spring in a stable equilibrium position. The spring is pulled 3 feet downward, and the object begins to oscillate. So 3 feet down. Let's assume equilibrium is just at 0. So this is where we start. And the object begins to oscillate, making one complete oscillation every 4 seconds. So that's a period equal to 4 seconds. So go ahead and sketch the rest of the graph. This will start below, so then it goes midline, above, midline, below. And so the next time it hits below, I know that that's 4 seconds. So here's our graph so far. With this harmonic motion, we're saying that the spring, the amount of displacement below will be matched above. So that's going to be 3 at the top. And we need an equation for the object. So if the period is 4, we know that that's equal to 2 pi over b. Solve for b. So b is 2 pi over 4, which is pi over 2. So here's b. And then I can get the midline just from my graph. So the midline is 0. And the amplitude is equal to 3 because the displacement is 3 on either side. As far as a phase shift goes, so if we're looking at a cosine graph, this looks like a negative cosine graph to me, then there's no phase shift, c equals 0. If we're looking at a sine graph, there is a phase shift. I'm going to say that my sine graph starts here and opens up. So what is that point? That point is 0 plus 4 divided by 4. The period is 4, so this is at 1 unit. This point's at 2 units. This point's at 3 units. The graph finishes at 4 units. So that means that C is going to be minus 1 because the sine graph has been shifted to the right 1 unit. All right, so what is the equation? That's the first thing we're answering. So we're going to give 2 equations. Let's just call this y again. So y is equal to, for the cosine graph, negative 3 cosine of pi over 2 times t minus 0 plus 0. I'm not simplifying those just so that we keep building into the same formula every time. If it's a sine function, the one I have marked off would be positive 3 sine pi over 2 times t minus 1 plus 0 again. And then there are some follow-up questions here. It says, at what 2 times within one cycle is the spring 2 feet below the equilibrium position. So this is asking, when does the graph, when do we hit -2? Now I'm going to go on the sine curve. It looks like 3 spots the way I drew this in, but remember we're talking within 4 seconds. So let me get my sine curve off of there. So I would be setting the cosine curve equal to -2. I could also be setting the sine curve equal to -2. So you could get two different um, values because it's not asking within the first, it's not asking about within the first 4 seconds. It's asking within one cycle. So on my cosine graph, it's here. On my sine graph, it would have been here and here. So just kind of take that with a grain of salt. If this were an AP problem, I'm assuming they would dictate which one of these two functions they want us to use if we have to do follow-up stuff with it. So I'm going to type in my cosine equation. So that's -3 cosine of pi over 2 times x. I guess I could put in the -0. This isn't really necessary. But anyway, that's my full equation. You could just get the zeros off. Pi over 2 times x is fine. And we're looking for when is this equal to -2 because it said 2 units below. Now you need to change the window here and use your graph to do that. The window should be going from 0 to 4. Doesn't matter what you count by on the x-axis. The y-min could be -3 and the y-max should be 3. And then we just press graph. And we're looking for these 2 points of intersection. So the first one is, let's see, let's show this work. Y is equal to -2 when t is approximately 0.535. And let's find the other one. You got to get your cursor closer to the other side so that it finds this value. Oh. Over the hump, there we go. And 3.465. And then we always want to label this. So I believe these are in seconds. Yes. So those are the 2 times, seconds, when y would equal -2. And again, if you use the sine curve, it would be 3.465 and whatever this point's going to be that's bigger than 4. So either set is fine. If this were on a quiz or a test and I wanted you to do this, I would tell you whether I want you to use a sine or a cosine model. So you would only be writing one, and then you would be using that to make your predictions. Oh, and then, sorry, there is one other question. Speaking to that, I guess. Use these values to find the next 2 times that it's in the same position. So this is worth looking at because remember, these things are periodic. So we can say, well, if we take our first answer and add the period to it, the period's 4, that should be the next time that we hit the next value. So let's take, well, gosh, I guess adding 4 to this, it would be 4.535. And then same thing here. If I add 4 to that, that would be 7.465 seconds. And again, that's what I could confirm as well if I continued this cosine curve on, if I let the window extend, I should see those next 2 points. So that's the idea that things are periodic. And remember, we talked about this way back in the beginning of this chapter. Periodic functions, they have the same behavior happening every period number of units, basically. Okay, number 12. A particle travels along the x-axis according to this position, where t is in seconds and s is the x-coordinate of the particle. What is the x-coordinate of the particle at 7.4? So part A is just asking us to evaluate s of 7.4. Right? So that's equal to 7 times the sine of 4 times 7.4. So -6.791. And we're not given labels here. This is just on the x-axis where we are. Part B, what is the largest value for the x-coordinate given the position of the particle? So the max displacement here is 7. So the furthest the largest value, not the furthest, but the largest value is that that the x coordinate could equal 7. So S of t has a max of 7. What is the frequency of this motion? So the period is equal to 2 pi over 4, which is equal to pi over 2. That means that the frequency is equal to 2 over pi. Remember, pi over 2 tells you how many cycles per second this graph completes. And the frequency tells you how many, oh, no, I'm sorry. Gosh, say that backwards. The period tells you how many seconds per cycle. How long does it take to complete one sine curve? And the frequency tells you how many cycles per second. This is how much of the graph gets done per second. Okay, number 13. When you board a Ferris wheel, your feet are 1 foot off the ground. That just sounds so weird. You're 1 foot off the ground when you board. At the highest point on the ride, your feet are 99 feet above the ground. Okay, so we have, let's start drawing this little graph here. When you board, you're at 1 foot above the ground. So let me draw my Ferris wheel first so I can connect it to the midline and stuff. Okay, so you're 1 foot above the ground here. At the top, you're 99 feet above the ground. It takes 30 seconds for the ride to complete 1 full revolution. That's the period. Period equals 30 seconds. And that's equal to 2 pi over b. So b is going to be 2 pi divided by 30, which is pi over 15. So we have that. We can also figure out the midline. The midline is 99 plus 1 over 2. So the midline is at 50. And then, just like we did in our notes, I'm going to draw this little sine graph. It's a little out of whack here, but 50, 99, and 1. And I guess it might not be a sine graph. It might be cosine. But we have D here. Write a trig equation for your height above the ground at t seconds. Find the 2 times where you're exactly 90 feet off the ground. So this says that we start 1 foot off the ground. So we start down here, and then we'll come back to midline, hit the max, midline, back here, and this takes 30 seconds. So this is a cosine curve. There's been no phase shift if it's a cosine curve. And if we make it a sine curve, just for fun, remember we say, well, what is this point here? This point is always 1/4 of the period. So 30 divided by 2 is 15. 15 divided by 2 is 7.5. So if we're talking about a sine curve, C is going to be minus 7.5. So drawing this model, we've got y is equal to negative. Oh, what's the amplitude? The amplitude is 99 minus 50. So the amplitude is 49, or 50 minus 1, 49, whatever. Negative 49 cosine of pi over 15 times t minus 0 plus 50. If you want the sine equation, y equals positive 49 sine of pi over 15 times t minus 7.5 plus 50. Find at what 2 times within 1 cycle you're exactly 90 feet off the ground. So let's use our cosine equation. When is y equal to 90? So putting this cosine equation into the calculator, I get negative 49 cosine pi over 15. Let's just put in an x there. And then plus 50. Now you don't need the parentheses around that because order of operations, the calculator will do pi divided by 15, and then it will multiply that answer by x. We're setting this equal to 50, and we need to make window adjustments here. the x goes from 0 to 30, and the y's go from 1 to 50. No, 1 to 99. And then you just press graph. Find these two times. Oh, I found the one on the right for me. 22.5. And what's the other one? We could probably use symmetry, but I'm already this far in, so get this past its middle points. 7.5. Those points should be the same distance away from the ends or the same distance away from the center or whatever. Oh, wait. Sorry, I set this equal to 50. I was supposed to do 90. Oop. Try that again. Okay, sorry about that. So let's make this 17.940 and 12.060, and those are labeled in seconds. Okay, last question. At high tide, the water level at a particular boat dock is 9 feet deep. So there's our max because it's high tide. Low tide is 3 feet. So we can find the midline right now. 9 plus 3 divided by 2 is 6. So there's the midline. There's the D. We can also find the amplitude. 9 minus 6 or 6 minus 3 is 3. On a certain day, the low tide occurs at 3 a.m. and the high tide occurs at 9 a.m. Find an equation for the height at time t where t equals 3 is 3 a.m. All right, so let's look at what we have here. So we've got a midline of 6, max of 9, min of 3. At 3 a.m., so just mark 3 off somewhere. At 3 a.m., you're at low tide. And then you'll hit midline, high tide, midline, low tide. At 9 a.m., we hit that high tide. So there's 6 hours between here. Means there's another 6 to finish the day. So that means that the period is 12. And setting that equal to 2 pi over b, that makes b pi over 6. This cosine curve has been shifted. So the phase shift, if it's cosine, is right 3 units. If it's a sine curve, we need to know what that point is. So that point, how far over is that point? Well, it's 3 units over to get here, plus an extra 12 divided by 4, so an extra 3. So this is at 6. Also, it's just halfway between 3 and 9. Okay, let's write our models. So y is equal to, for the cosine curve, negative 3 cosine of pi over 6 times t minus 3 plus 6. If we're working with the sine curve that starts here, then that would be y equals positive 3 sine of pi over 6 times t minus 6 plus 6. And there's a question here that says, what is the water level at 2 p.m.? So we're thinking military time here, right? Because t equals 3 is 3 p.m. So we're not going to be plugging in 2. 12 would be 12 p.m. So you're going to be plugging in 14. You can plug it into either one of those functions. If you're kind of shaky on the phase shift thing, it's best to plug into the function that you didn't have to do any math on. So the cosine function, just in case you messed up your math on this phase shift, you're more likely to get the first one right, where they told you where the first point was. So just keep that in mind. But both of these should work. I'm just thinking test strategy-wise. So we're putting in 14 for t. So it's going to be 14 minus 3 and plus 6. 3.402. We've got to label that. This is labeled in feet. So that's the level of the tide at 2 p.m. All right, that finishes this worksheet. Please come into office hours if you have any questions.